Welcome once again to another fascinating math video. In this video, we shall be considering solving problem from a matrix. And in matrix, we are looking at finding the eigenvalues of a matrix. The eigenvalue of a matrix is otherwise called the characteristic value of the matrix or the latent roots of the matrix. All right. So before we go back to the solution of the problem on the board, I'd like to inform you that I offer a private online math tutoring service. So if you're in need of this service for the primary level, secondary level, or the college level, be very free to get across to me because I have a practical teaching experience which spans over a decade, and I've been involved in tutoring various students. So I have the capability to instruct students in such a way that they will understand mathematics. So be very free to get across to me if you're in need of this service. So let's go back to the solution of this problem. Is to find the eigenvalues of this matrix. Now, for us to be able to solve this problem, you should know that eigenvalues arises from equations that are of this form. Ax equals to lambda times x, where the A is a square matrix and x is a column vector, all right? And lambda is a scalar. Now, for non-trivial solutions, the values of lambda rather, are called the eigenvalues of the matrix. When we say non-trivial solution, we mean when this column vector x is not assuming the zero vector, such as this. All right. Now we're not looking at this case. This is a general case. All right. We're not looking at this case. We're looking at other cases where this vector can assume values entries other than zero. Can be 1, 2, 3, any other values. So for such, the value of lambda is called the eigenvalue of the matrix. All right. So to solve this problem, what we shall do, we shall take this expression on the right-hand side to this way. So in doing so, we shall have ax minus lambda x, and we'll be left with a zero vector. Please take note, this is not zero as in arithmetic, rather it's a vector. That is, it is this, all right? So when we say zero, we mean this vector over here, all right? So we have this as a result. Now we shall do what is called post-factoring. Now we can post-factor. If we post-factor, we shall be having a minus. Now you may suggest that what will be in the second subtrahend will be lambda. If you say so, you are wrong. Lambda is just ordinary number. All right. So why this is a matrix? So removing a number from a matrix does not make any sense. So to balance things up, removing this x expression, we shall put the identity matrix, which is I. All right. And this should multiply x. Well, this is what we mean by post-factoring, and this equals to the zero vector. Can you see that? Now, for this to have non-trivial solution, the determinant of this expression must be zero. But before that, let's simplify this further. Now, the matrix here is given to us as 2, 1 and 2, 3. So I can come here and write 2, 1, then 2, 3. That is the matrix A minus lambda, which is a scalar. Then this is the identity 2 by 2 matrix, and that is written as 1, 0, 0, 1. All right? Then multiplied by x. Your s, you can call your x sub 1, x sub 2, because it's a vector, as I said earlier on, and this is equals to 0. All right? Now, simplifying this further, we have it as 2, 1, 2, 3, minus. This multiply each entry, we have lambda 0, 0, lambda. Can you see that? Multiplied by x1, x2, all equals to 0. So further simplification of this, because this, if you observe the order of this matrix, this is a 2 by 2 matrix, this is also a 2 by 2 matrix. That means that they are conformable to subtraction. So subtracting corresponding entries, we have the result as 2 minus lambda, or 1 minus 0 will give me 1, all right? Then we have 2 minus 0 over here will give me 2. So you have to subtract corresponding entries. Don't forget that. Then 3 minus lambda will give me 3 minus lambda, all right? All multiplied by x1, x2, and that will give us 0. Now, for this equation, this 0 here, don't forget, is a 0 vector. For this equation to have non-trivial solution, the determinant of this matrix here should be 0. That is, the determinant of 2 minus lambda, 1, 2, 3 minus lambda should be equals to 0. Now, how do we evaluate determinants? We take this, we multiply the elements in the leading diagonal. So let's multiply this and this, which I'll be having 2 minus lambda multiplied by 3 minus lambda. Minus 2 times 1 times 2 will give me 2, and that should be equal to 0. So this is how to evaluate the determinants. Now, on expanding this, we have it as 6 minus 2 lambda minus 3 lambda plus lambda squared minus 2 equal to 0. All right, so we have this expression at hand. On simplifying it, we have it as lambda squared. Now, minus 2 lambda minus 3 lambda will give me minus 5 lambda. All right, then 6 minus 2 will give me plus 4, and that is equal to 0. Can you see that? Very, very interesting. All right, now we can factorize this expression. When we factorize this, we have it as lambda square plus, okay, we cannot actually factorize it because if we test the determinant of this expression, it will give us complex roots. You observe that? Yeah, it will give us complex roots. So we cannot do, will it give us complex roots? Let's observe it carefully. Okay, let's test for determinant first. Determinant is given by b squared minus 4ac, right? And b here is minus 5. So we have minus 5 squared, that is 25. Minus 4, a is 1, and c is 4. All right, so it's factorizable. And that will give us a is 1. Sorry, this times 4. This will go 16. 16 minus 25 will give us 9. And 9 is a perfect square. All right, so that means it is factorizable. So we can actually factorize it. So let's go over to factorizing this. What do we use to factorize this expression to make it simpler? Okay, we can write this expression as lambda squared minus lambda minus 4 lambda, because minus lambda times minus 4 lambda will give us 4 lambda squared. All right, then plus 4 equals to 0. Now, grouping this, factorizing this by grouping, we have it as, take these two expressions. We have lambda minus 1. Then bringing out 4 here, we have 4 brackets lambda minus 1. And that is equal to 0. So factoring 4, that we have lambda minus 1 multiplied by lambda minus 4 equals to 0. All right? So we use the zero product property. In using that property, we shall have it as lambda minus 1 equals to 0, or lambda minus 4 equals to 0. All right, let me take this part of the board now. We're almost done with the problem. So from this first equation, we have our lambda equals to 1, and from this second, we have our lambda equals to 4. So these values you see here, we call them the eigenvalues or latent roots of this particular matrix. So we're done with this particular video. In the next video, I shall be teaching you how to find the eigenvector of a matrix. All right, but for this, it suffices to stop here. So if you are in need of a private online math learning service, it's very free to get across to me. Also, don't forget to like the video, share it, and make your comment. Thank you very much.